All right, so continuing on, so let W be the set of vectors that look like this, or any of the other, A, B, or C. A, B, and C's are real numbers, right? And find out if this set of vectors, find if there is a set of vectors to say that W equals the span of that. And if it is, then it's going to be a vector space. And if it's not, give me an example of why it's not a vector space. All right, so again, this is my set W. So if I tried to write this as A times something plus B times something, so that I could say that the W is equal to the span of a set of vectors, right? Like a V1 and a V2, like I was just doing on the previous page. If I can find a V1 and a V2, then I can say it's a span of a set of vectors, then I can get it as vector space. But what happens when I try to factor out an A? I get a 3 and a 1 and a 0 here, and then I'd get a 1 and a 0 and a -5, but I'd also have this extra thing, 0, 4, 0. So I can't, because it's got this constant, this number here, I cannot say that V is, W is the span of these vectors, so this is not a subspace. So not a subspace, since not a span of a set of vectors. So there's more than one way to show it's not a subspace. Right here, I could say there's no 0 vector, because I could let A and B equal 0, but that's not the 0 vector. That leaves me with 0, 4, 0. So it's not a subspace in many different ways. All right, so let's see if I can break this up. Factor out an A, factor out a B, so I get a -1, a 1, and a 1. If I factor out a B, I'd get a 0, a -6, and a 2. Oh, but I still have this 1. So this is stopping me, right? So I can say it's not a vector space because it's not going to be written as a span of a set of vectors, or I can just go right to saying there's no 0 vector. I let A and B equal 0, I still get this, right? So not a subspace. All right, let's look at this one here. So if I factor out an A, I'm looking at all the different constants in here, and a B, and a C. So A, I'd have 1, 0, -1, and 0. Factoring out B, -1, 1. 0 and 1, and factoring out C. Okay, so I can say that this set W is the span, and I'll just show you another way. I don't have to label them as V1 and V2 and V3. I can just literally write them in my set. So, comma, -1, 1, 0, 1, comma, 0, -1, 1, 0. So since I can say W is a span of these 3 vectors, this is a subspace. All right, one last one here. If I break this up, it could be A times 4, 0, 1, -2, plus B times 3, 0, 1, 0, plus C times 0, 0, 1, 1. And since this number here is a 0, I don't need to worry about it. So I can say that this set W is the span of these 3 vectors, comma, 3, 0, 1, 0, comma, 0, 0, 1, 1. So there it is. Therefore, it is a subspace.